So I think one of the most important results in complex analysis is a lemma called Jordan's lemma. And Jordan's lemma is, it is helpful for doing integrals of this form. So this goes from minus infinity to plus infinity. We have some real function, f of x, and we have e to the power I omega of x, where omega is some real constant. Okay? So this is x is real, and omega is real. Okay? So, of course, I mean, you will recognize that these are the kind of integrals that we do when we're doing a lot of Fourier analysis, right? So suppose lambda of r is a semicircular contour of radius r. Okay, which is centered at the origin. Now let m of r be a positive real number, which is be the maximum of the modulus of f of z evaluated on gamma of r, right? So yeah, we have some so we have some, let's take it to be on the upper half plane. So we have some semicircle like this, or this is not a very good semicircle. And this is radius r. And we can say, okay, let's look at this function over this r, and the real value, the highest real value of this guy is m of r. Okay, that's just m of r. Now, in addition, let omega be positive. So if omega is not positive, then you can look at the other plane. So, the lower half plane or something like that. So, and in the limit, and let omega be 0, and that mr goes to 0 as r goes to infinity, okay? If this is the case, then Jordan's lemma tells us that the integral of f of z e to the power I omega of z d of z goes to 0 as r goes to infinity. Okay. Okay. So as a result, what do we have is that if I do the integral of f of z e to the power I omega of x d of x, then this integral is going to give me 2 pi I times the sum of the residues of the function on the upper half plane. Okay, so this should be fairly obvious now. if omega is less than 0, then the Jordan's lemma tells me that f of z e to the power I omega x, sorry, this should be x. This should be x. D of x is going to be 2 pi I. There's a minus sign. And the minus sign comes from the fact that you have to change the orientation of the contour, because when we do Cauchy's integral theorem, the contour integral is taken in the counterclockwise direction. Okay? And because of minus infinity to plus infinity, you have to change the orientation of the contour. And that is going to be given by minus 2 pi I, the lower half plane, sum over the lower half plane of the residues of f of z e to the power I omega z. Okay? So this is Jordan's lemma. Okay, so let's do an integral application of Jordan's lemma.